Good morning, everyone, and welcome to today's presentation. I'm Dr. Mayuri Rani, and I'm delighted to have you here. Today, we will be discussing quality management system in brief. This is the first slide, so I just want to give you a quick overview of what's to come. We'll explore the fundamentals of quality management, its importance, and key components. I promise to keep it clear and engaging, so let's get started. Let's start by considering the materials we need, including all reagents and consumables, which are fundamental for ensuring consistency and reliability in our results. Next, we look at the instruments involved. Making sure they are properly calibrated and maintained is key to accurate outcomes. Moving on to the procedure itself, it's crucial to follow each step carefully to avoid errors and variability. Personnel play a vital role, as trained and experienced staff are essential for performing the process correctly. The environment also matters. Working in a clean, controlled setting helps prevent contamination and preserves sample integrity. Speaking of samples, patient samples must be handled with care, ensuring proper collection, storage, and processing to maintain their quality. Contamination is a significant concern because it can compromise our results, so strict protocols should be in place to minimize it. We also rely heavily on kit instructions provided by the manufacturer. Following these precisely ensures we're using the reagents and tools correctly. Lastly, we need to be aware of variables that can affect quality, things like temperature, timing, and even operator technique, all of which can influence the accuracy and reproducibility of our tests. Connecting all these points, it's clear that attention to every detail, from materials and personnel to environmental conditions, is vital for achieving reliable, high-quality laboratory results. Let's take a closer look at the most common factors that affect quality. These are the key elements that can influence the success of any project or product we're working on. First, we have process variability, which refers to inconsistencies in how tasks are performed. When processes aren't standardized or controlled, it can lead to defects or errors. Next is human factors, things like skill levels, training, and attention to detail. The more skilled and well-trained the team, the higher the quality we can expect. Then, we have equipment and tools. Outdated or poorly maintained equipment can cause issues, so ensuring we have the right tools is crucial. Materials also play a big role. Using high-quality raw materials helps prevent problems downstream. Lastly, environmental conditions, such as temperature, humidity, or workspace organization, can impact quality as well. Connecting these points to our overall theme, understanding what influences quality allows us to implement better controls and improvements, ultimately delivering better results and exceeding customer expectations. Responsibility is a crucial concept that runs through everything we do. It's about more than just doing what's expected. It's about owning our actions and their outcomes. When we take responsibility, we demonstrate accountability and integrity, which build trust and credibility. In the context of our overall theme, responsibility connects to how we can create a positive impact, both individually and as a team. It's about recognizing that our choices matter and that we have a role to play in driving success. Embracing responsibility encourages proactive problem-solving and a mindset of continuous improvement. So, in essence, it's about being reliable, trustworthy, and committed to doing our best at all times. Let's take a closer look at quality control, starting with internal quality control. This involves the processes and checks that are carried out within the laboratory or organization to ensure that our results are accurate and reliable. It's all about maintaining high standards from within, through regular calibration, quality checks, and internal audits. These steps help us catch errors early and keep our work consistent. Now, external quality control is just as important. This involves participating in proficiency testing or interlaboratory comparisons, where we compare our results with those of other organizations. External control helps verify that our methods align with industry standards and that our results are credible outside of our own setting. When we talk about types of quality control, we're referring to the different approaches we use to maintain and improve quality. Internal quality control includes routine checks and controls we set up ourselves, while external quality control involves independent assessments by outside agencies. Both are essential for a comprehensive quality assurance system. Connecting this to the overall theme, implementing both internal and external quality control strategies ensures that our testing processes are accurate, reliable, and trustworthy. It's about creating a robust system that continuously monitors and improves our work, ultimately safeguarding the quality of the results we deliver. Let's talk about IQC, which stands for Incoming Quality Control. This is a crucial step in our overall quality management process. Essentially, IQC is all about inspecting and verifying the quality of materials and components when they arrive. The goal here is to catch any defects or discrepancies early on, before they make their way into our production line. By doing so, we prevent potential issues down the road that could affect the final product quality. Highlighting the key points, IQC helps us ensure that only materials meeting our standards are used, which directly impacts the reliability and durability of what we produce. It's also about maintaining consistency, making sure every batch of incoming materials is up to par. This step connects to the broader theme of quality assurance because it's the first line of defense. If we don't catch problems early, they can escalate, leading to higher costs and customer dissatisfaction. So, IQC plays a vital role in safeguarding our standards and supporting continuous improvement in our processes. Now, let's talk about inter-laboratory quality control, which is a crucial aspect of maintaining high standards across multiple labs. This involves comparing results between different laboratories to ensure consistency and accuracy. It helps us identify any discrepancies early on and address them before they impact patient care. Moving on to external quality assurance schemes, these are programs where an external body provides samples or data for labs to analyze. The goal here is to objectively verify that our testing methods are producing reliable results. It's a kind of external audit that helps us maintain credibility and trust in our laboratory outputs. Then we have external quality control, which is closely related. It involves participating in these external assessments regularly. The key point is that external quality control provides an additional layer of oversight beyond our internal checks. It's a vital part of continuous quality improvement, ensuring that we meet national or international standards. Connecting all these points back to our overall theme, they underscore the importance of systematic monitoring and external validation. By engaging in these schemes, we ensure our laboratory results are accurate, reliable, and comparable across different settings, ultimately supporting better patient outcomes. Now, let's take a closer look at some key measurement concepts that are crucial for ensuring quality. First up is the CV percentage, or coefficient of variation percentage. This metric helps us understand the variability in our data relative to the mean, giving us a sense of the consistency or precision of our measurements. Next, we have measurement uncertainty. This is all about acknowledging and quantifying the potential errors or deviations in our measurements, which is essential for making informed decisions based on the data. Then we come to LJ charts, which are useful tools for visualizing and analyzing measurement data over time or across different conditions. They help us spot trends and identify areas that need improvement. Following that, SD, or standard deviation, is a fundamental statistical measure that tells us how spread out our data points are around the average. It's a key indicator of the variability in our process. Finally, all these elements tie into the broader goal of measurement of quality. By understanding and applying these concepts, we can better monitor, control, and improve the quality of our products and processes, ensuring we're consistently meeting our standards and delivering value. Let's talk about the key elements that help us maintain quality. First, we have policies, which answer the question of what to do. These are the guiding principles and rules we set to ensure consistent quality standards. Next, processes refer to the way we do things. These are the steps and workflows that keep our operations smooth and efficient. Then, we have procedures or SOPs, which are the detailed instructions on how to perform specific tasks. ensuring everyone knows exactly how to carry out their responsibilities. Records are also crucial. They serve as written evidence of our compliance and performance, like temperature logs or daily QC records. These records help us track and verify that everything is running as it should. Finally, tools for achieving quality encompass all the resources and equipment we use to meet our standards. Together, these components form a comprehensive system that supports consistent quality in our work. They connect to our overall goal of delivering safe, effective, and reliable products or services. Remember, having clear policies, well-defined processes, detailed procedures, accurate records, and the right tools is essential for maintaining high quality across the board. Let's take a moment to look at the key standards and reference materials that support our quality assurance framework. First, we have ISO 15189-2022, which is a crucial international standard specifically for medical laboratories. It sets out the requirements for quality management and technical competence, ensuring our lab results are reliable and consistent. Next, there's NABL 112, which is the National Accreditation Board's guideline that aligns with ISO standards, but tailored for our country's context, helping us meet local regulatory requirements. We also rely heavily on standard textbooks, which serve as foundational references for best practices and scientific principles in our field. Kit inserts are equally important. They provide detailed information about the reagents and tools we use, ensuring proper handling and interpretation. Lastly, referral documents are vital for effective communication and data sharing between different labs or healthcare providers, ensuring continuity of care and accuracy in patient management. All these resources collectively reinforce our commitment to maintaining high standards and delivering accurate, trustworthy results. They form the backbone of our quality system, connecting everything we've discussed so far in this presentation.